Good day, good day, good day, good day. Welcome to our other lesson. So if you are watching this video for the first time, I will advise that you subscribe to our channel. Today I'll be focusing on the quadratic sequence. In the previous videos, I managed to do the arithmetic as well as the geometric sequence. So today I'll be covering the quadratic sequence. So again, I will advise that you go through our playlist. You can go and check each playlist. We've got a playlist for life science, for maths, and also for physical science. So today, without wasting any time, I'm going to go straight to what they will be expecting learners to know with regard to quadratic sequence in grade 12. So, and also some of this will apply to also grade 11s. First thing first, with a quadratic sequence, you normally will expect a sequence which will have A as well as B as well as C. So in other words, this sequence looks more like a parabola, because we know a parabola will look like ax squared plus bx plus c, which will be the general formula of a parabola. So in other words, a quadratic sequence and a parabola, they somehow relate because they all have got A, B, and C. So now when you're dealing with a quadratic sequence, remember from arithmetic sequence, if you're to be given a sequence, let's say it's 4, the next number is 7, the next number is 10. This sequence, we can find the common first difference, which you will take 7 minus 4, which will give us 3, then take 10 minus 7, which will give us 3. So we've got the same common difference, which is 3. This will be our common difference, which will be 3. That's how you will find the arithmetic sequence, as we did the last time. So now, let's say now I give you a sequence. Let's say now I've got 4, and then let's say I've got 9, and then let's say now I've got let's say 16, for example. Let's say this is our new sequence now. I've got 4, I've got 9, and 16. So now if I were to find the common differences for this sequence, I know 9 minus 4, that will give us 5. Then 16 minus 9, that will give us 7. So now I have a problem. I'm no longer having the same common difference like we did in the previous example of 4, 7, and 10. So now our common difference is different. Then that's when now we apply what we call the quadratic sequence. So with quadratic sequence, we always look for the second common difference. So we're going to go and look for the second common difference. And again, the same concept will apply. You will take the second common difference, you will minus it by the first difference. So 7 minus 5, that will give us 2. So in other words, this will be our first difference. This will be our first difference. Then this 2 here becomes our second difference. So that's how we'll end up finding our quadratic sequence. So remember, with arithmetic sequence, we end up on the first difference. Quadratic, we go to second difference. So now, in other words, this means the first difference of a quadratic sequence will always give us an arithmetic sequence. Because I've seen some questions where they ask learners to find the Tn of the first difference of the quadratic sequence. So remember, the first difference of the quadratic sequence will always give us the arithmetic sequence. But to solve the quadratic sequence, we need to find the second common difference. No? So now, these are the formulas that you guys need to become aware of. Remember, for us to do the quadratic sequence, we need to have A, B, and C. So in other words, I need to find my A, also find my B, and also find my C. So to find A, so the first thing we need to do is to find A, because I'm having A, B, as well as C. So this means that the first thing that we will need to find will be to find our A. So to find A, now, this will be the formula. It will be 2A is equals to your second difference. So to find A, you will equate 2A with the second difference. That will be to find A, right? So in other words, in this example of ours, our second difference will be 2. Therefore, to find A in this example, you will do 2A is equals to your second difference, which is 2. So we know to solve for A, we will divide both sides by the coefficient of A, which is 2, right? So you divide both sides by 2, So this 2 and 2 will cancel. Therefore, A will be equals to 2 over 2, which will be 1. Therefore, our A will be 1. So now we need to go and find B as well. So to find B, this will be the approach. To find B, you do 3A plus your B will be equals to the first, I call this the first difference between T2 and T1. So 3A plus B is equals to the first difference between your T1 and T2. So this will be, remember, this is T1, this is T2. So the first difference between T1 and T2, which is 5. So in other words, 3A plus B will be equals to 5. So in other words, 3A plus B will be equals to 5. And now to solve for B, therefore, I already know what A is from the previous example. So it will be 3. And then what is our A? Our A is 1. So you put 1 plus B, which I'm looking for, it will be equals to 5. 3 times 1 will give us 3. So this will be 3 plus B will be equals to 5. So B will be equals to 5 minus 3. So B will be equals to 2. So therefore now I've got my A. I also have got my B, which means now the last thing that I need to go and find will be our C. So we need to find A, B, as well as C. So to find C now, so it will be, this will be the formula to find C. To find C, it will be A plus B plus C will be equals to first term in your sequence. It's equals to first term in your sequence. So now we already know this will be A plus B plus C. What is the first term in our sequence? It's 4. That's the first term in our sequence, which is 4. So therefore, A we know it's 1, which we just found. And then what was the B that we found? Remember, we found B as 2. B was 2, so it will be 1. B is 2. I'm looking for C. And then our first term was 4. So now 1 plus 2 will give us 3 plus C, which will be equals to 4. And then C will be equals to 4 minus 3. 3 will go there, that's right. So now 4 minus 3, that will be 1. That will be 1. So in other words, now I've got A, I've got B, and I've got C. Therefore, my general formula or my Tn will be, remember, it will be A n squared plus Bn plus C. That will be the format of my quadratic sequence. Since I'm doing with numbers, it will be n. But for parabola, we'll do with x, since we're doing with x and y values. So now, we need to put each value to where it's corresponding to. A, we know it's 1, so I'm going to put my 1 there. So it will be 1 n squared plus, what is our B? Our B, we know it's 2, just 2n. Then what is our C? It's 1. So we know mathematically, any number times 1 will always be equals to that number. So 1 times n squared, that will be n squared. And then plus 2n plus 1. So we'll expect our Tn to be n squared plus 2n plus 1. So I always tend to prove whenever I have time in the exam. Let's say if I'm done with an hour to spare, I can go and prove and test. For example, if my Tn is like that, will this correlate to my sequence? Let's check. Let's find T1 using the same Tn. So my T1, wherever I see n, I'm going to put 1. So this will be 1 plus 2. I see another n, I put 1, then plus 1. Then I'm going to add everything to get my T1. 1 squared is 1. So it will be 1, then 2 times 1 is 2 plus 1. So this will be 1 plus 2 plus 1, which will give us 4. So our T1 will be 4, which is same as our T1 in our sequence. Then now I need to go and to prove further. Let's just test and find T2 as well. So again, wherever I see n, I'm going to put 2. Now I see another n, I'm going to put 2 plus 1. So 2 squared, we know that's 4. 2 times 2, that's 4, plus 1. So 4 plus 4, that's 8, plus 1, that's 9. So our T2 is 9. So therefore, so far now I know that the pattern of my sequence will be 4 and then 9, which is going the same route as the sequence we had. So remember our sequence was 4, the second number was 9. So you would expect T3 to be 16. So for interest sake, let's also prove if our T3 will also be 16. So this will be T3 will be equals to, wherever you see n, we're going to put 3 now. So this will be 3. So wherever we're going to see our n now, we're going to put 3 so that we can continue. Remember, so far we've done T1 and T2. So now to find our Tn, we're going to find, we're going to have to put, so now remember we found our T1 and T2. So again, wherever I see n, I'm going to put 3 for this one to find our T3. So it will be that, and then it's 2. I see another n, I put 3, then plus 1. So now to simplify this, 3 squared. So now to simplify this, I know 3 squared, that will give us 9. And then plus 2 times 3, that will be 6. Then plus 1, that will be us simplifying our thing. So what is 3 squared will be 9, then 2 times 3 is 6, and then plus 1. So then for our answer will be, our T3 should be 9 plus 6, which will be 15, plus 1, that will be 16. So T3 will be 16, meaning this correlates with our sequence. So in the exam room, we'll be happy that the Tn that we found, which was n squared plus 2n plus 1, therefore it is accurate. So for practice sake, let's also do another example. Let's just do another example just to test if we'll be familiar with the quadratic quotient. So again, let's just say now they give us another sequence. Let's say they give us 3. And then let's say they give us 3. And then they give us second number. Let's say it's 9. And then let's say they give us 17. Okay. And then now we test them to see if we get the same common difference. So first thing first, 9 minus 3, that will give me 6. And then 17 minus 9, that will give us 8. So in other words, in the exam, because we can be able to see our sequence, because that will be 9 minus 3, that will be 6, okay. And then, yeah, then in 8, that will be 8 sharp, then we're covered. So now this will be our first difference, right? Our first difference. That's our first difference. So our first difference, we know that it's giving us those 2. But remember, for quadratic, we'll continue and get the second difference. Again, it will be 8 minus 6, which will give us 2. So 2 will be our second difference, right? Second difference, that will be 2, our second difference. So now, again, remember, we need to go and find the Tn, or the general formula. So remember, the Tn, because we're doing with n numbers, so it will be an squared plus bn plus c, right? So now, to find our Tn now, remember the first thing, we need to find a. To find a, it will be 2a is equals to our second difference, which is 2, right? So therefore, we divide both sides by 2 to get a. So a will be 2 over 2, which will be 1. So in other words, we divide both sides by 2, also by 2. 2 and 2 will cancel. Therefore, a will be 1. 2 divided by 2 will be 1. Now we need to go and find b as well. To find B, again, to be 3A plus B will be equals to, remember, the first difference between T1 and T2, which is 6. The first difference between T1 and T2, which is 6. So 3A plus B will be equals to 6. And then 3, what is our A? Our A is 1 plus B is equals to 6. So this will be 3 plus B will be equals to 6. So in other words, my B will be 6 minus 3. B will be equals to 3. That will be my B equals to 3. Then I will continue and find my C. So to find C, it will be A plus B plus C will be equals to the first term in the sequence, which is 3. So the first term is 3. So A is 1. What is our B? Our B is 3 plus C is equals to 3. This will be 4. 4 plus C will be equals to 3. Therefore, in other words, 3 will be equals to 3 minus 4. C will be equals to negative 1. So therefore, our Tn will be 1n squared. So therefore, our Tn will be 1n squared plus, what is our B? Our B is 3. So it will be 3n plus our C. What is our C? Our C is negative 1. So we will simplify that, which will give us 1 times n squared will be n squared plus 3n. Then a plus a negative, that will give us negative. So it will be minus 1. That will be our Tn. N squared plus 3n minus 1. So now I've got my Tn. So now what I need to do is to test and prove if this will correlate with my sequence. So my Tn, to find my T1, wherever I see n, I'm going to put 1. So now I've got n. So I will put 1. This will be 1 squared plus 3. I'm going to put 1. Then minus 1. And then T1 will be, what is 1 squared? 1 squared will be 1 plus 3 minus 1. So my T1 will be 1 plus 3, that will be 4. 4 minus 1, that will be 3. So T1 will be 3, which so far I know is going with my sequence, which is 3. So T1 is 3. Then I go and test also to see if T2 would also correlate. So wherever I see n, I'm going to put 2. It should be 2 squared plus 3. I put 2 minus 1. So what is 2 squared? It's 4. 3 times 2, it's 6 minus 1. So this will be 4 plus 6, it's 10. 10 minus 1, it's 9. So my T2 is 9. Again, T2 is 9. Again, for interest's sake, I can go and find T3. What will be T3? T3 now will be 3 squared plus 3 minus 1. So what is 3 squared? 3 squared is 9. What is 3 times 3? That's 27 minus 1. So then what is 27 minus 1 will be 26. Then 26 plus 9, 26 will be 3 times 3. What will be 26 times 1? Just realized I was doing 3 cube. So 3 times 3 is that will be 9, not 27. 3 cube will be 27. So I did 3 cube by mistake. So 3 times 3 will be 9. So what is 9 plus 9? That will be 18. 18 minus 1, that will be 17. So I'll be happy that it's going with my sequence. So yeah, 3 times 3 is 9, not 27. 3 cube will be 27. So that will be your sequence. So you'll be happy that your sequence is correct. So that means that my Tn will also be accurate. So now let's continue with our sequence. For example, we've got 3, we've got 9, we've got 17. So let's say now they want us to find the next 2 terms. Let's say they want us to find next 2 terms. Next 2 terms. So to find next 2 terms, so you need to go and look at the pattern that the first 3 are giving you, which is 3, 9, and 17, right? So we know so far the first difference here will be 9 minus 3, which will be 6. 17 minus 9, that will be 8. So in other words, if this sequence was to continue with the same pattern, this means the difference here is 6, the difference here is 8. Remember, the first difference always give us the arithmetic pattern. So this one is giving us 6, this one is giving us 8. The next difference must give us 10. Will give us 10. So if it's giving us 10 now, 17 plus 10 will give us 27. So meaning the next difference will give us 12. So just going to continue like that. For example, if we go the forward route or the addition route, 3 plus 6 give us 9. 9 plus 8 give us 17. So therefore the next term will be 17 plus 10, which will be 27. To get the next term, 27 plus 12, which will be 39. Therefore, we know the next difference will be 14. Again, we will continue. 39 plus 14 will give us the following terms, and so on and so on. The next one will be 16, and then just add the number here with 16 until you get the corresponding number. So that's how you can find the next two terms of your quadratic sequence. So in the next video, I will do those type of questions where they won't give us the numbers. For example, they can put x as a variable, then they ask us to solve for x, or they give us a statement, and then they want us to go and solve the statement. So I'll be doing those type of questions in the next video. So in the meantime, I hope this one will be helpful to you guys. You guys will be able to become aware of how to simplify or how to get the general formulas. So far we've done arithmetic, we've done for geometric. Now today we just did for arithmetic. So sorry, for quadratic. So meaning all the type of sequences, if ever they're going to ask you guys for a general formula, you guys will be aware of them. And then if you've got any questions or maybe something that was puzzling you in the section, I'll advise that you comment on the comment section with regard to anything, then we'll be able to clarify it. Thank you guys, and please press the like button and also subscribe if you are new to the channel. Thank you very much.